Good. So, hi. My name is Jakub Beránek, and I would like to welcome you to this Rust Prague Meetup. It is the third meetup that we have this year, after we have kind of restarted this meetup after, I think, 6 years or something like that. So this is a new run. As last time, I would like to thank Martin Dětský and the Department of Distributed and Dependable Systems, because they allowed us to be in this beautiful venue. Last time it was almost full. Today we don't even need so many spaces, but it's okay. It's a nice venue nevertheless. I would like to also ask you that if you would like to have some talk or presentation, lightning talk, anything at this meetup, we prepared a form. So if you would like to speak about anything you like, you can submit your proposal and we will schedule it for one of the following meetups. We already have some interesting topics scheduled for the next meetups, but you can pretty much apply anytime you want. Also, if you don't want to talk yourself, but you want to hear someone else talk about the topic that you are interested in, we have a Discord, and on the Discord you can pretty much just say, I would like to hear about topic X, and maybe someone will come and create a presentation about topic X. So I think there was already some question about combining OOP and Rust, or like moving from OOP language to Rust, and we will have a presentation about that in the future. I don't know when, but there should be one, okay. So just to recapitulate what has happened since the last Rust meetup in Prague, we had the first Rust meetup in Ostrava, which was quite nice. We had, I think, about 40 people. I had some live demo about how to create a simple web application in Rust in 1 hour. So if you would like to take a look, it's on this link. And Ada was also speaking there pretty much with very similar talk as will be today. And there were also some guys from Espressif, which is a company that is doing all sorts of embedded stuff in Rust. So if you are interested in embedded, there was a lot of interesting information, I think. So this is the recording, or you can just try to find it on YouTube. Then there was the, let's say, another Rust Prague meetup, which is organized by the Brains company. And Pavel had a talk there about doing safe or safer Rust. There is no recording, right? But I think that we can later publish your slides. Yeah. Okay, so we should have at least some output from that. And as a reminder, I created this website where I'm trying to gather all the information about Rust in the Czech Republic. So if you are interested, you can check it out. There is an RSS feed, so you can kind of subscribe to what is happening with Rust in the Czech Republic. So rustlang.cz. Okay, and one last thing that has happened since the last Prague meetup. I said last time that Rust has applied into Google Summer of Code. I don't know, how many of you know this program? What is Google Summer of Code? Okay, about half. So it's some kind of program by Google where essentially they help young open source contributors and students to start contributing in existing open source projects, right? So they kind of pair the organizations with the open source projects and the students, and they pay them some money so that they can work on those projects for a few months. And since the last time, we have actually announced the selected projects last week, and we have received 9 projects, which is actually quite a lot for a first-year organization. So this is the list of the projects. I think that they are quite interesting to the Rust community, so I will just quickly go through them. So the first project is about improving cargo semver checks. Does anyone know cargo semver checks? Okay, it is a cargo subcommand, so something you can install into cargo that will check the API compatibility of your crates, right? So if you have semver compatibility and, I don't know, you do some change in your library, like you remove a public function, and you don't bump the major version, this tool will tell you automatically, for example on CI, that your library is no longer semver compatible, right? So you can automatically check if your changes to the library are respecting semver, which is quite nice. So in this project, some open source contributor will be improving this tool to add some configuration so you can say like which API lanes you want to have, which you don't like, and so on. The second project is an improvement of the CraneLeaf CodeGen backend. Does anyone know what is the CraneLeaf CodeGen backend? So the Rust compiler has a number of backends that generate code for your programs. The default one is LLVM. It generates very efficient code, but it's hell of a slow. So it's kind of slow to compile. CraneLeaf is an alternative backend written in Rust, actually, and it generates slower programs, but it is faster to compile, right? So it is a trade-off. And you can actually change your CodeGen backend when you compile your programs, so you can make your compilation a little bit faster if you use CraneLeaf. But it is still kind of not as fast as it could be, so this project is essentially making it faster, right? So that's the gist of it. The third project, so this will be mentored by me, and this is essentially improving the benchmarking infrastructure that we have for Rust, right? So I don't know if you sometimes check this website, perf.rustlang.org. It is essentially a benchmark suite where we keep essentially benchmarking every commit to the Rust compiler and checking out if there are some regressions, improvements, and we can see some charts and stuff like that. So the goal of this project will be essentially to improve this, to make the front end better, make more charts, and so on. The third project is cargo shell completions. So who knows what is a shell completion? Okay, so yeah, this is Windows, so it will be hard to demonstrate. But shell completion is that you start typing something into your shell, then you hit tab, and it auto-completes, right? It's a very cool thing. Who uses clap in their Rust programs? Right, so clap is a very popular library for defining command line parsers, and but it doesn't do the completion. It doesn't know how to do dynamic completion, so that I can write like cargo run or something, or my program do something, and then hit tab, and it would autocomplete. So this project is essentially adding this dynamic completion to clap, and also to cargo, because cargo uses clap. Okay, so this, I think if this would be finished, it would be a real nice improvement to clap. The other one is, yeah, so that's just, the Rust compiler has a bunch of tests written in Bash. We don't like Bash, we want to have them in Rust, so this writes them into Rust, long story short. This is an internal refactoring of Rust FMT. I don't know a lot about that. This is, yeah, so has anyone heard about the .NET CodeGen backend? So there is a guy that is creating a new CodeGen backend that creates .NET assembly, or IR, from Rust code. So he tries to kind of combine the worlds of .NET and Rust, which is pretty cool. And here Google will be sponsoring him to work on this. The penultimate project is sandbox prog macros. So there were a couple of proposals about these sandbox prog macros over the years. The idea is that right now, if you run a prog macro, it can be quite slow because it is being recompiled or on every compilation. And also, it can, like, if you use SQLX, the prog macro will actually connect to an SQL database while it is being compiled, which is quite crazy. The sandbox part basically means that the prog macros will be isolated, and they will be running in WebAssembly. So you will be able to compile your prog macros into WebAssembly so that they are completely isolated, so it will be safer. And also, we will be able to cache them, so it could be faster. So this is like the bootstrapping process of that work. And the last one is, does anyone know Miri? Yeah, this is like a crash course into Rust tools. So Miri is, let's say, a compiler plugin or some kind of tool that you can run over your code, and it will interpret the Rust code, and it will find undefined behavior in it. So if you use unsafe, right? If you don't do unsafe, you don't need Miri, right? That's the great thing about Rust. But if you do use unsafe, you can have some UB in your code, and in that case, Miri will tell you that something is wrong. And this essentially adds support to async to Miri so that it can interpret async code that uses I/O and socket and so on. Therefore, it should be easier to use Miri on Tokio, for example, on projects that use Tokio, right? Which is the asynchronous I/O runtime. So yeah, so that's the 9 projects that we got. It's really a lot, but I'm glad that Google gave us so many opportunities to improve the ecosystem, right? Back to the topic that I want to talk about today, and that is Rust community events, right? So this will not be a super technical talk. I will just be talking essentially about the conference in Netherlands where I was last week, and I will be just trying to present you a lot of new stuff that is going on in the Rust ecosystem so that you know like what is being discussed, some new features on the horizon and so on. First, let me just show you how many events there are. So does anyone subscribe to This Week in Rust? Okay, so this is like a newsletter where every week, essentially, you can see what is going on in the Rust project. And if you take a look at the bottom part of the newsletter, there is the upcoming events part. So you can see that just pretty much in this week, this is just virtual events. This is European events, North American events, I don't know how to pronounce it, Australia, essentially, right? And just today, we have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, here is our meetup in Prague. And I think 9, 10, 11, 12. So 12 meetups in Rust happening just today all over the world, right? So it's like the community is not so small. People are actually meeting and talking about Rust. And one of those communities is this one, so that's quite nice. So there's a bunch of events, and I would really like to recommend you to go to these events. And I don't have to tell you this because you're already here, but another kind of event apart from meetups are conferences. And I think those are also pretty nice. So I will just go through a few of the best or known largest Rust conferences. So probably the most best known conference is RustConf. This is like the official conference, which is actually being also organized by the Rust Foundation this year. So it's like super official this time. Last year, there was some controversy regarding this conference. Maybe you saw it on Hacker News or Reddit or some other places. Essentially, the organizing team did some stuff that wasn't very nice to one of the speakers. Hopefully, this won't repeat this year, so we'll see if it will be okay. But in any case, if you want to meet like the people that actually work on Rust, this is probably I would say the best opportunity for that because there will be a lot of them. It is in Montreal though, so you would need to go to Canada. But there is something much closer. In October, there will be Eurorust, and I think last year it was in Brussels, before that in Berlin, and this year it will be in Vienna. So that's like 2 hours, 3 hours, 4 hours max by train from here. So if you'd like to go to some really big, I would say nice Rust conference, I think that this is the best opportunity this year because it will be in Vienna, which is quite close. And I'm actually trying to convince the organizers of this conference to do it in Prague next year. I have absolutely no idea if that will work, but I hope so. In any case, if you know some venue in Prague where we could have a Rust conference for about 500 people, please do let me know. I would be really interested in finding some cool venues so that I can convince them to bring this conference to Prague. Because I think it makes sense. It's Eurorust, Berlin, Vienna, Prague. It's kind of the similar, so I think that would be quite nice. Then the third, probably largest Rust conference is Rust Nation, which is in London. It was this year, I think, in February or something like that. And the recordings of all those conferences are usually found online. So if you're interested in what is happening on those conferences, you can just go to YouTube and try to find some interesting talks. So for example, this year, there was a talk from JD, who is my boss, like the leader of the infrastructure team. And he was presenting, like, what does it take to keep the Rust infrastructure running, right? Like the Rust is a very big project, and it has a lot of releases, crates, and just software that needs to be downloaded by people. And this is kind of very difficult to even keep it running, like everything is on fire. So it's, I think, quite interesting to listen to, like, what does it take to get this working. Then there was a presentation by Emmanuel, who is actually the team leader of the libs team. So he takes care of upgrading the Rust libraries. And did anyone ever heard or dreamed about a stable ABI for Rust? So is there someone who doesn't know what is ABI? It's fine, I can explain. Okay. So API, application programming interface, is essentially some interface between programs where you can, for example, call functions or call some REST endpoints with JSON and so on. So it's a way how to define an interface, how programs can communicate. ABI is something similar, but it exists on the much lower level. Essentially, it's on the level of the processor and the memory and the operating system. So what is the calling convention? If I call a function, and it takes a parameter, how do I give it a parameter? Is it through the stack? Is it through the registers? Which registers will be used? So it's much lower level than APIs. And also, it's kind of unchecked. Like there is no checking mechanism. Like if you get it wrong, you get a seg fault. There will be no nice exception or anything like that. And famously, or infamously, Rust doesn't have a stable ABI, unlike, for example, C++. But there are some use cases where stable ABI would be nice. For example, if you want to compile a part of your program with an older Rust compiler and a part of the program with a newer Rust compiler, this is not possible today, but with a stable ABI, it would be. So in this presentation, if you're interested, Emmanuel explains how we could do it, how we could introduce stable ABI to Rust. Right? There's actually a competing proposal that talks about how to enable calling Rust functions from other languages, like without going to the C ABI, which is already possible. And that is called CRABI, like CRAB I, CR ABI, but there is something different, right? So this is essentially stable ABI between Rust components. So if you're interested, you can take a look. Then there was a talk by John Jenkset. I never know how to pronounce it. Is there anyone here who knows who this guy is? So he's kind of, I would say, famous popularizer of Rust. He has a lot of YouTube videos where he explains deep dives into Rust concepts. He has like 4-hour, 5-hour videos where he really tries to explain everything there is about async and FFI, traits, and stuff like that. So if you really want to understand some Rust concepts, I would encourage you to look up this guy on YouTube. He has really excellent videos. And in this talk, he was kind of explaining how you can make your Rust programs impeccable, which means like bulletproof. So Rust programs are usually quite stable by themselves, like they usually don't crash and so on. But he shows a bunch of tools how you can take this even further, like Miri, or for example, also some profilers, benchmarks, and so on. Then there was a talk by Pietro Albini, who is a former lead of the infrastructure team, and he was explaining what is ferrocene. Is there someone who heard about ferrocene before? Okay, so the ferrocene is essentially a qualified version of the Rust compiler. This means that if you have a qualified version of a compiler, you are essentially allowed to use Rust to program devices that will be running in cars, for example, or in safety-critical industries, right? So C and C++, they have like a 30-year head start in this area because they have all the qualified compilers and certifications and so on, but Rust doesn't. But actually it does now, because last year there were a few qualified compilers released. So as of now, you can actually use Rust to implement programs for safety-critical areas like automotive or maybe even airplanes, I'm not sure. But this will probably improve in the future, right? So this is pretty cool. And the TLDR version of this is qualification means that you essentially document everything about it. Like you just write hundreds of pages of how does this work, and that's it. That's the qualification, right? Because you cannot perfectly check that the compiler is perfect, but you can document it. So that's it, okay?
So does the compiler itself need to be modified or not? It's just about
the compiler, so they have essentially, ferrocene is essentially a fork of the compiler, but they don't do almost any modification to it, or they upstream the modifications. They just document it. I think they use like Google Docs to write like a 300-page brutally complicated document that just says, like, so for example, we have about 15,000 basic tests for the compiler, and they went through all of them and said, this test tests this specific feature from the language, and it is implemented in this part of the compiler. Right? So one additional thing that they needed to do is to build a reference for Rust. Because again, infamously, unlike C++, Rust doesn't have a specification, it doesn't have a standard. But for something like this, you need to have some standard. So they created their own version of a Rust specification standard so that they could qualify the compiler. And there is also now actually a movement officially sanctioned by the Rust Foundation on the project where some people are actually working on a Rust standard as of this moment. So it will take years, but it is being worked on. So maybe in a few years we will have a Rust standard and C++ people can stop laughing at us. Okay. Then there was also talk from Nicolas Young from Vercel. I don't know if any one of you does front-end stuff, but there is this turborepo tool that some JavaScript developers use for their projects. And essentially, they decided to rewrite it from Go to Rust for some reasons. And in this talk, you can kind of go understand how did they do it. Like, how do you go from a big Go application, and how do you move it to Rust piece by piece? Right? They didn't do a ground-up rewrite, but they did it incrementally. So if you use Go or any other language and you are thinking about porting your application to Rust, I think that this is a nice talk to see what they went through. And the last talk that I wanted to show was from Lars Bergström from Google. This talk was kind of popular online because it made some claims about C++. Essentially, Google has been evaluating how their developers work with Rust, and they found out that Rust developers in Google are twice as productive as C++ developers in Google. So of course, this was kind of controversial online. Again, a lot of Hacker News comments and so on. But I think that the talk is actually quite nice, and they explain how did they measure it and why are they even doing this? Like, why are they moving to Rust? That it is giving them some advantages. So again, this could be seen in the talk. And lastly, after the Rust Nation conference, there was a meeting of the Rust leadership. So there is some kind of I will give you a link at the end of my presentation. I did a whole talk about how does the Rust project work and its governance in January. There are a bunch of teams, and those teams have leaders, and those are kind of like the decision makers in the Rust project. And they had a meeting in London after the conference where they were basically discussing like what to do forward with the whole project. So you can find more details on the official Rust blog if you're interested. Okay, and then the thing that I actually wanted to talk about, which is RustNL. So last week, there was a conference in Delft in Netherlands. It is called RustNL. It was the second run of the conference. The first one was last year. It was in this venue, which looked like some hall where some serial killers are hiding their corpses. It was kind of scary at first. It was like these industrial buildings with nothing around them. But actually, it was quite cool in the end. We arrived there by boat, so that was pretty cool. And yeah, there was about like 500 people. So it was a great opportunity to, like just talk to people and find out what are they doing with Rust. There was several companies and with like the banners and stands and so on. And like half of the companies were embedded, so there were a lot of embedded companies. I really was surprised how many different embedded companies use Rust, and the rest was essentially web services. Right? So if you went to a conference, you would probably think that Rust is like embedded and web services, and you wouldn't be wrong, because in our survey, that's pretty much one of the largest use cases. Yeah, and then there was also a stand by the Polars team. Did anyone hear of Polars? Yeah, so Polars is a library that essentially, it's something like pandas in Python, so something for working with data frames and tables, but implemented in Rust. And they were so successful with it that they actually like raised a lot of funds and got a lot of money, and they had like 6 people in there, so it's no longer a tiny, I think it was started by one person, but now it's actually a company, which is pretty cool. Anyways, so what was on RustNL? So in the first day, there was a presentation from Rick, who is working on MakePad. MakePad is one of the many UI tools that you can use to create user interfaces in Rust. But I don't know did anyone hear of MakePad before? Yeah, I didn't think so. It's kind of, so it's actually some kind of an integrated developer experience where you can like write your UI and your program, and it's kind of live reloaded. So for example, if I change something here, like this is normal Rust code, but if I change something there, it is like live editing the environment, which is also rendered like within the editor. So normally when you use Rust, it doesn't live herald, right? This is a very weird experience. But for UIs, you need very quick feedback. So a lot of UI frameworks are doing some kind of magic with macros and custom DSLs so that you can get, for example, this nice live reload. So in this presentation, he was actually like bragging about what his tool can do because it's quite cool. Like he started this whole editor as another tab inside of this editor. So like it can literally run itself recursively and do a lot of stuff. So, and it's also very fast. So if you'd like to work on UIs in Rust and you are not afraid trying something new, you can try the MakePad. The second presentation was from someone who works in the European Space Agency, I think. And they are using Rust in space, which is quite cool. So they have some satellites, and those satellites have some kind of scientific devices that do science, whatever. And some of these devices are now being programmed in Rust. So again, I found it pretty cool. Then there was a presentation by Alice Reel, who is actually a maintainer, one of the main maintainers of the Tokyo project. So if you know Tokyo, maybe you saw her nickname, Darkson, sometimes on GitHub. And she also works for the Rust for Linux project. Did anyone hear about Rust for Linux? Okay, so Rust for Linux is an initiative to smuggle Rust into the Linux kernel. And essentially, now there is some basic infrastructure, and you can write drivers and some kernel modules, I think, in Rust. But it is a bit annoying because you need a nightly compiler and a bunch of features. So very often they need to redo the whole thing because the compiler breaks them. So essentially, she was discussing like what changes we can make to Rust so that they don't need to depend on so many unstable features, which is quite interesting, but you can watch the talk. One of the things that they need is they need to have their own smart pointers, right? Because Arc and RC or Box are kind of special, and they cannot implement them by hand, their own versions in the kernel. Why are they special? Well, for example, if you have RC, it allows you to do some type coercions. So if you have something like let's imagine that this is RC. RC I32, you can coerce it into RC din trait if this trait is implemented by I32. But this coercion, this conversion between those two types is only possible for some blessed smart pointers in the standard library. You cannot implement your own pointer that would do this. And this is quite annoying for the Rust Linux people because they need their own smart pointer. So they are essentially proposing some incredible hack that because discussing what does it take for something to be a smart pointer will take years, they're essentially proposing just stabilize this derived smart pointer, but we won't stabilize what does it expand into, we will just stabilize that it makes this thing magically to be a smart pointer. And in that case, they will just enable this coercion for custom types, but they don't need to discuss what exactly it will do inside. So it is a quite hacky solution, but maybe it will work for them, we'll see. They need to go through the RFC process, which is quite painful. So this RFC was posted 2 weeks ago, and it already has more than 50 comments. So it's like if you someday post an RFC into Rust, RFC is basically a document where you say, I want to do some change to Rust. So if you do post it someday to the RFC's repository, be prepared that you will receive a lot of comments because a lot of people have a lot of opinions about what you want to change, right? So it can be quite difficult to get something changed in Rust. Yeah, and the last talk was from Mara Boss. Does anyone know the name, Mara Boss? So again, she's one of the leaders of the library team. She wrote a book called Rust Atomics and Logs, which I can highly recommend. Like if you're interested in parallelism, concurrency, how do mutexes work and logs? Great book. It doesn't even need to be about Rust. It's really great. And she was announcing essentially it wasn't even an announcement. It was just some kind of an idea how we could communicate better within the Rust project. And essentially what she would like to have is some kind of map where we would kind of say, those are the things that we want to do with Rust, like performance, binary size, embedded use cases, Rust for Linux, and create some connections within them so that people can actually see like what is going on in Rust projects, what are the things that I can work on. If some company wants to fund me for working on Rust, like what is needed to do, right? So because we don't have an idea what is going on in Rust today. Like I have some idea, but I watch like 50 different channels and I'm all the time connected. But still, I don't have a good idea what is going on because it's like hundreds of people over the world doing something. So yeah, creating some kind of roadmap like this would be pretty nice, and yeah, I would like to work on it once I finish my PhD. So yeah, in the afternoon, I wasn't there, so let's skip that. This was a talk about how to teach Rust. So I will be teaching a new course on Rust in Ostrava starting in autumn, so this was very interesting to me. So if you're interested in how you can teach Rust in your team or university or school, take a look at this talk. This last talk was about Postcard, which is some form of, let's say, serialization format for SERDE, which is pretty optimized for embedded devices. So if you're working with embedded and you need to send data from one embedded device to another, this can be a nice approach. And he was discussing some new addition that is kind of building an RPC system on top of Postcard, right? Because often you don't need just the communication format, but also some sort of RPC, like calling between two devices. And this talk was about replacing OpenSSL. So does anyone heard about Rust TLS? Right, so it's actually it's pronounced Russell's. It's quite weird pronunciation. Yeah. So Russell's is a reimplementation of OpenSSL in Rust. It's actually quite feature complete and very fast. So I'm actually trying to use it everywhere I can. It's no longer like an experimental thing. But some people, they still have like C libraries that link to OpenSSL. So they cannot just start using a Rust library, right? So the goal of this project that is being talked about in this call is essentially you take Russell's, a Rust implementation of OpenSSL, and you wrap it with a C API that is like backwards compatible with OpenSSL, right? So you just compile it as a dynamic library, and then you use it in your Linux system. And before you know it, you will be actually using Rust TLS for everything. But the interface for the C programs will look like it is the good old, bad old OpenSSL. Right? Okay. And why I wasn't here? Because I was on a parallel track that was called the industry track. This was mostly like focused on companies. So there were like 50 people from different companies that wanted to learn about how they can start using Rust. The first talk was from Frederic Amey, who is working for Ampere, which is some kind of daughter company of Renault. It is actually a big company. It has like 10,000 employees. And they are essentially doing research and development. And they are using a lot of Rust for like logic inside their Renault cars, which is quite cool. And I think if I remembered correctly, in 2026, the first Rust code should appear like in an actually manufactured Renault car. So if you buy a Renault car in 2 years, maybe it will be running on Rust, right? So it is like the language is actually getting into embedded use cases and all sorts of things. I'm sorry? To be honest, I'm not sure. I'm not sure if they use Ferrocene because there are actually more qualified compilers. There's also one from Infineon. So I
As you mentioned, without ISO certification,
yeah, without, I think they mentioned that they want to go all the way to ASIL D, which is, I think, the like more strictest form of qualification. But I don't know a lot about this certification, so I'm just like trying to remember this. But yeah, they probably need some. There are also like different parts of the car, and like for brakes, you need certification. For the radio system, maybe not so much. So I think they are starting with like the less strict parts of the car. He had this nice observation that essentially, and this is something that I agree with, that if you give even very complicated and nasty code to a Rust developer, the chances that they will do something bad with it are much lower than, for example, in C++, because the compiler just won't let them. So I think this is an observation that kind of ties into code reviews are, in my experience, easier in Rust than in other languages, because just like the person had to go through the compiler, and there was like a complex battle already. So if it's green, if it compiles, probably the nastiest things are not there anymore. Anyway, then I had a talk about like the state of Rust, which I wanted to show here, but I think I already talked for too much time, so I will probably skip it. Essentially, I was showing just some charts about like how many people use Rust. Yeah, that's it. Like, what was the history of Rust? What companies are using it, and so on. Maybe I can just show one. Yeah, so this was a funny moment because I was talking about the history of Rust, like that it was developed in Mozilla, and then I realized that in the room there is Nico Matsakis, who is the author of the Borrow Checker, and who was literally there in Mozilla at the time. So yeah, I realized it's not such a good idea to talk about these things that I know nothing about when there is someone in the room who was literally there. Anyway, yeah, I was like explaining why is Rust good. I think that's I don't need to do here. Yeah, one statistic, we have almost 150,000 packages on crates.io, which I think is quite nice. Blah, 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 blah. Yeah, those are the areas where Rust is being used the most. Backend applications, cloud, embedded, and then a lot of other use cases in the long tail. But web applications definitely win, at least in our survey that we did last year. And yeah, of course, this is a very thankful quote because people always laugh when I show it, that Rust is endorsed by Linus Torvalds. And yeah, if you use Python, use Rust. It's the fastest linter, and it's being used by everyone, and it's written in Rust. It's pretty great. Yeah, I was trying to like tell people that they can run Rust anywhere because it runs literally anywhere, which is quite nice. And yeah, so there is about 12% Rust developers in various services, like in JetBrains and Stack Overflow service. So it's not a niche language anymore. Like it's on the level of Kotlin, Go, Ruby, and other languages, right? And just 5 years ago, it was only 2%. So the trend is growing very fast, right? So that's essentially what I wanted to say here. And even the ecosystems, like I think we are not that far from Python, but we are growing very quickly. Like this is the number of packages on crates.io, which is growing very rapidly. And the number of package downloads is actually growing exponentially. So like people are really using Rust more and more, and it grows exponentially, which causes all sorts of issues for the infrastructure team. And basically this was like my main message, that Rust is no longer niche, so when companies want to adopt it, they will not have to go through all these like pain points of a very young technology, but at the same time is not yet fully mainstream, right? Like Rust is not Java yet. So if they adopt it here, they can ride on this stock market trend and maybe get some competitive advantage against other companies, right? So that was a marketing thing that I wanted to show the other people. And yeah, and just quickly, the second day, there was a talk from Sofia Turner who announced the June language. Did anyone hear of June last week online? Okay, it was in some, again, Hacker News. She announced her new systems programming language that is kind of, it's designed to be like Rust, but without the lifetimes. So it should be like easier to use than Rust. It uses some compromises and trade-offs. Yeah, I would say it's an experiment. Like if you're interested in language experiments, check out June. I'm not sure if it will work, but maybe we'll see. Then there was another UI presentation about Robius. Robius is something like Flutter for Rust. So it is supposed to be a framework for developing UI applications on mobile that does everything, like the UI, the interface with Android and iOS and hardware and everything. So if you're interested in mobile development, check out Robius. Then there was a talk by Volkert, who is a really cool guy. He is currently writing a bunch of stuff from C to Rust, like a lot of foundational libraries. For example, he wrote NTP, the network time protocol, which is now both faster and more, like has better quality in time resolution than the original. And yeah, he really likes this cartoonization process, which is essentially evolution into a crab-like body plan. So he's trying to evolve a lot of C programs into Rust. And right now he's working on rewriting zlib, which is like the foundational compression library. And again, it's safer, obviously, but it's also, I think, a bit faster than the original. Well, the original is super slow, but even like the optimized zlib ng version. So yeah, if you're compressing something, you can try zlib-rs and do it in this new fast implementation. And the last part, Embassy. Does anyone use Embassy on embedded? Okay, so if you do something on embedded, Embassy is essentially a way how to structure your application with async. So you can like say that this interrupt, this hardware interrupt is an async task. If you don't know what is hardware interrupt, you probably don't need to worry about this. Another talk was from Raf Leviem, who built Xylem. Does anyone know Raf and read his blog? Okay, one. He's the author of Druid, and he did a lot of stuff in the Rust UI ecosystem. Maybe we'll hear about it in Ada's presentation, about some related stuff and libraries. Yeah, so this guy really loves GPUs. Like, he could spend 3 hours talking about GPUs and how to use them to draw UI. So check out his talk if you're interested in high-performance UIs. This guy built a Rust firmware for his smartwatch. And the last presentation was from Nico Matsakis, who I already talked about. He's the author of the Borrow Checker. And he was essentially explaining how can you, as a software developer, understand something like this if you are interested in type systems and experiments. So it was like a crash course into type theory for busy engineers. So if you're into that, I recommend checking out this talk. Okay, and after the conference, there was the unconference, which is the very last thing that I want to talk about. And who knows what is an unconference? Okay, so unconference is essentially that you lock a bunch of people into the same building, and you force them to talk with each other for the whole day, right? So there is like no structure. You just literally put those people into a building and just say, talk to each other, right? And discuss interesting ideas, come up with stuff, have discussions and all sorts of things. There were 2 tracks about UI and embedded. The embedded people, the TLDR is that what they want are smaller binaries. Not surprising. Rust sometimes generates quite bloated binaries. On embedded, binary size is incredibly important. So we spent discussing several hours about how to make binaries smaller. And there are some concrete outcomes. So oh crap, I didn't find it, but I think I can do it quite quickly. Yeah, here it is. So essentially, someone proposed that we will create a CFG feature, so like a normal Rust feature for the standard library. And this feature will be telling the library, now optimize for binary size instead of performance. Because the standard library is really optimized for performance. Like, for example, if you count the number of Unicode points in string, it uses some kind of huge lookup table to optimize this as fast as possible with SIMD instructions. But this is totally worthless on a small microchip, right? Or if you want to rotate a slice, I think there are 4 separate implementations in the standard library. And in runtime, it dynamically chooses which one is the fastest. But again, like 4 implementations, 4 times the code size, right? So for embedded, it sucks. So essentially, what these guys are proposing is to just create a feature optimized for size. And then when you will use opt level S or Z, this will be set. And in the standard library, there will be some CFG options. Like, if I'm optimizing for size, just do this stupid, slow thing that generates a few instructions. If I'm not optimizing for size, do this crazy SIMD super optimized thing. Okay, so that's kind of the general idea. And they also were discussing static mute. Is anyone here using global variables that are static and that are mutable? That's nasty, right? But on embedded, they actually do kind of need it because it's like a different world. But this is becoming deprecated. Like literally, it's possible that from a some future Rust version, if you use a static mute, it will be like a deprecation warning. So they were discussing like some alternatives what to do instead. And then the UI people, they want a faster compiler because, of course, everyone wants a faster compiler. So we were discussing the Vile project, which is some form of incremental linker that is being developed right now, and also a bunch of stuff how to make compilation faster. And they also want some, let's say, ergonomic improvements. This was the number one on their list. It was the number one also year before, so nothing has changed. And that is auto-cloning into closures. Did anyone stumble upon this? So just a very quick explanation. So let's say that you have some state. Wow, English keyboard, that's hard for me, but I will try it. You have some state, and then you do something like, I don't know, Tokyo, spawn, and now you need to, how is pipe? Okay. Imagine pipe. No, English keyboard is the worst. Okay. Sorry for that. Good. And now you need to do something like and now you can finally return, for example, some async closure, right? And now you can start using this. So this clone thing is very annoying because if you have UI code, like in some form of React Lite framework, you need to do this all the time. You need to clone, 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 and you need to write this manually. And did anyone encounter this in their code? Yeah, I think it's a quite common ergonomic nuisance. So essentially what they want to do is just let you do this. They want to, like one of the solutions proposed is there will be a new capture trait, and this capture method will be called when you capture something into a closure. So for arc, the capture would like automatically increment the reference count when it's captured into closure, and therefore you wouldn't need to call clone. But that's just one of the proposals. So this is one thing that they wanted, and the other thing was partial borrows. Did anyone run into problems with borrowing? It's kind of a stupid question. Yeah, so partial borrows is some form of, so again, the issue, Nico Matsakis had a blog post about this, and the issue is that you have, for example, some struct that has like 2 attributes, and now you need to have, now you have some methods that take reference to self or reference to mute self. You borrow one of these attributes, right? And then you want to call another method. But it won't, the borrow checker won't let you because you are holding a reference to one field, and then you want to take a reference to the whole struct. Because it doesn't see that in this method you will be using a different field, for example. So yeah, again, one of the solutions how this could be improved is that, for example, there will be some kind of annotation that you are borrowing just one attribute of the struct or something like that. But yeah, this is quite controversial because this shouldn't appear in public APIs. That would be like a somewhere hell. So maybe just we could do this for private methods, who knows. But this is just like one solution, but the problem I think is clear. Like the borrow checker cannot reason about disjoint borrows across methods, which is quite annoying. And it's also weird because it can do it for closures. Since Rust 2021, if you have a closure and you borrow just one field of a struct into it, it will work. But for methods, it doesn't work. So yeah, it's an ergonomic thing. You need to refactor your code to make it work, which is annoying. UI people don't like annoying, so they want to get this solved. And the last part of the Ancon was the project. So there was like the people literally working on Rust. I was there for most of these discussions. We were discussing the edition system. Long story short, the last edition was 2021. The next one is 2024. What happened is that no one was working on 2024 until like November last year. And then someone said, okay, 2024 is around the horizon, so we need to do this. So we have 1 month to finalize your work on 2024. Right? So we kind of forget that there will be a next edition. We didn't know. So we are discussing like how to make this better in the future, because it is chaos everywhere. In general, the Rust project is one big chaos. It's like 500 people, volunteers working in their own free time, doing just some things that they like. And we're discussing that we essentially need some form of project management. Like literally some person that will be going around asking what is going on, what are you working on, could you work on this thing because it's a priority, and so on. And we don't actually know what are our priorities, so that's like a separate sub problem. We're also discussing burnout, big issue. All the volunteers, they do a lot of work. They start taking on more and more and more work, and then they burn out. They just cannot physically handle it anymore. So yeah, this is quite bad in open source. So yeah, don't do too much stuff, especially if it's unpaid. And we're discussing Nico's, basically, he has a proposal about doing a roadmap for the next 6 months of Rust, which he calls project goals. So if you see this on some blog post, I think it was already on the official Rust blog, you can propose your own goals for Rust. Like, what should we prioritize in the next 6 months? If you have good ideas, check out the Rust blog. There is a call for proposals. Yeah, and if you are interested in how does the Rust project work, like how do the teams interact, who makes changes in Rust, like how does the language evolve when there is no company, no board or anything that controls it? How does it work? If you are interested in that, I had a talk about that at the first Rust Prague Meetup this year in January. So if you want to check it out, here is the recording. So sorry for, again, having a non-technical talk. I know that some people expect a lot of technical stuff, and this was not it, but I have a lot of technical topics in my backlog, so don't worry. But yeah, I just wanted to tell you like what is going on in the Rust project in the last few weeks. So that was it. So thanks. Does anyone have any questions? Okay, no questions. So we will take a short pause so you can refresh a little bit from all this talking, and then we will have our second talk from Ada. So, thanks. talk from Ada. Ada actually introduced me to Rust, so that was quite nice of her. And she works at the Ostrava Supercomputing Center and at ACS, which is
Alignment of Complex Systems.
yes, alignment of complex systems at MFF.
No, it's part of the Charles University, but not. It's AI Safety Research Group.
Okay, and she will tell us how to make better slides and how to use Rust for that.
So thank you for introduction. I do different things. Sometimes I have talks about them, and I am like not satisfied with the state of the art of the tools how to make the slides. So my talk will be about, we'll have two parts. One is like how to make a better slides and how it's actually implemented in Rust. So if you read some book about slides, and then you will get some advices how to convey emotions and things like this. So if I want you somehow persuaded in the Rust that if you use Rust, you will feel safe and comfy and things like this, that probably I will use slide like this. If I want to convey the emotion like that using Rust is cool and it's dynamic, and then I will use slide like this. But sometimes you also need to create some technical presentations, and just conveying the emotions is not the right thing. Or, of course, even technical presentation can convey some kind of emotions, but you also, sometimes you have to explain some complex topics, so you need the complex figure and so on. And what people are doing in many cases, they just put everything in one slide, even just because it's a complex topic, so I can make a complex slide. So this is just a slide from random presentation, and it's about quantum computing. Quantum computing is complex topic, so I can just put everything in one slide. But what I will do let's say I'm not familiar with the quantum computing, and this slide appears. So people are reading from the left to the right, from the top to the bottom, so I will probably read this. But then what? Some people will start to look on the circles, maybe, this is something rainbowish, so I will look here. There is some small letters, small numbers, and now each different person in the audience will just look in different part of the image. And I, as a speaker, have to, again, gain the focus. And it will take some time, it will take some mental energy of me, mental energy of the audience. So I think that it can be done in different way. And so let's have an example. This is from the presentation about the Git, the versioning system. And it's from my presentation a few years ago. And it's in the middle of the presentation. So people already know that this rectangle means repository, and the icon means the icon of the user. So we have a fairy creates her first commit, and there is a main branch, and then she do some work. She create 2 extra commit. She also creates another branch, and so on. And if we now she wants to create a new repository. It's called origin in this case. She push to this repository the main branch, so it will copy just the commits that is needed for the main branch, and we again put the label to this, and also the fairy's repository will know, okay, the origin has this branch. This is not a tutorial about the Git, so I will just skip the rest of the story, and it's terribly slow, sorry. But on normal computer, it's very fast. Okay. So this is the final slide. But if I would just show you the final slide without the story, it will be still the same problem. Like, you will have no clue where you should be focused. Like, should I read this text? Should I read these trees? It's a mess. But if I am, because it's a complex thing, so I'm telling you a story, but my slides has to follow the story. If I will just show you, because we went through all these simple steps, you have no time to read any other text that is on the slide because there was no extra content. You had only one point where you could focus. And of course, this is not a new idea. If you have ever been on some Blackboard presentation, then you know where you should look. That on this, you should look here. Like it's obvious that you should not look here. And also, if you are working with the Blackboard, I have to draw the pictures one by one. I cannot just click and put the complex thing to you or present to you in one step. So it also, the Blackboard somehow follows the story. And I think that I'm not saying let's forget about the slides and get back to the Blackboards, but just let's take some things that are good things from this approach, and I think still makes sense to have, for some topics, Blackboard presentations, and let's integrate these ideas into the slides. And why people are not doing this? Or at least I have visited lots of presentations where even the talk was good, but the slide was bad. And I think that the main reason is that the tooling itself is quite wrong. Or it should be the first-class feature of the slide software, not something like if I want to create this kind of 25 steps presentation, let's say PowerPoint, I would probably kill myself. Or okay, then PowerPoint is Turing complete, so I can program anything. So I can also program slide revealing, but the tool is not guiding you to do this to do this way. And if I would just create 25 separate slides and now say, okay, I want to have this box different size or color, then I would have to change 25 slides. Of course, in case of Beamer, the LaTeX presentation tool, it's slightly better, but I think that the Beamer is wrong on so many levels. I can discuss it after it or maybe during the presentation, but yeah. There are some tools that somehow can do some of these things, but I think that it's not ideal, so people are not doing it as much as they should. And this is the reason why I've created this tool. Actually, this is the 5th generation of the tool. The first one written in Rust, the previous was mostly pure Python. And the most users right now has the 4th generation. The presentation that you have seen from Jakub, that it was done in the 4th generation. So this is quite new, and not all users migrate. But it's just a matter of time. So let's look how it works from the user perspective. And even it's written in Rust, the interface itself is actual Python. It's very, very thin layer of the Python. Like everything, if you call some function, it's immediately go to the Rust, but I will speak about it more. So how it looks like from the user's perspective, you just import the package. From the package, I'm importing slide deck, which is just the set of the slides. I am now instantiating the slide deck. Then I will put a text into the slide. I will call the render. So it will create a PDF with just one slide, one page that looks like this. Yeah, I think that it's quite important to understand why it has a Python interface, because the programming slide, even it sounds weird on the first side, I think that it's quite important concept. I will return to it in few moments, but first, let's just focus on step revealing if you do not want to program that much. And it's just, you can use basically any editor, vector, or like Inkscape or raster like Krita, GIMP, or whatever. So this picture is actually from Krita, the screenshot. And then you can create the layers, and if you create several layers and you name the layers, then you can control when is something appear or disappear. And if there is so we have three layers. One is the cog, one is the letter N, and one is the ferry. And the cog has no annotation, so it will always appear. Letter N has annotation 2+, so it will be visible from step 2 and more. And ferry has annotation 3+, so it will be visible from step 3 and more. Other language is slightly more expressive, but let's have this simple example. So if I will put this image into the slide, now I'm using Aura format. Aura format is basically PNG images with the layers. So because I need to still have names of the layers. And almost every editor can export to this format, but you can also use SVG that has natively layers inside. And if I will put the image it will automatically be broken down to several pages. And first we have just the cog, then we have an N, and then we have a ferry. So this is just the simple way how you can control how to show and hide things on the slide. For things where I tend to be more visual, I'm using it a lot. Of course, there are people that do not like that much. Jakub is one of them. Then he strongly prefers just the programming way. So let's talk about how to program slides and what is useful. Let's assume that I want to explain to you what is sieve of Eratosthenes. Probably you know the algorithm, just pretend that I'm explaining it to you. So I would need the slides like this. Like we want to find we want to find prime numbers in the range of the numbers. And I will cross out the numbers by orange color. So an algorithm is like, take the first or smallest non-crossed number, and this is number 2 in this case, and this is a prime number. And now I will cross out all multiples of the 2. And again, I will take the first not cross out number, it's 3, it's prime number, and I will cross out all multiples. And 5, and so on. So I'm not now teaching you a sieve of Eratosthenes. So I have this 25 steps or something like this. Even if I will use all the Inkscape or whatever tool or PowerPoint, I would probably, again, make lots of mistakes filling these right boxes and so on. So why not I think that it's quite natural, like, okay, there is something repetitive, I want to use cycles, I want to use conditions and so on. So this is the Python code that generates this 25 slides. It's 19 lines of the code, so it's quite dense. It's less than 1 line of the code per page. I don't want to go too much to the details, but the important mechanism is this in steps. So let's assume that I want to draw a green box, which is done like this. I will just create a box. Box is layout primitive, something like div in HTML. And I can just set a width and height, and the color is green. And by default, everything is centered on both axes. So we have a green box in the middle. So let's now assume I want to create a semaphore. Like I have a green thing, orange thing, and red thing. I can create 3 separate slides, or I can use this in-step mechanism. This is basically the same code, but instead that the background color was constant, I'm not now saying background color is some special object that should set the value in first step, it should be green, in second step it should be orange, and in third step it should be red. And then this will generate this sequence of the slides. If I want, let's say, I want that not only change the color, but it should be also bigger. I can also set the width and height as in-step values and change the sizes in different steps. Yeah, there are lots of other things about the steps. You can just make a sequence and put another sequence. In the next version, there will be hierarchical steps, not only natural numbers and so on. But I will end the explanation of the tool itself. Just my main message is that the reason why I've created this tool is because I want to control what user is or audience is seeing and what not, and I can do it in programmed way, and I have lots of control over the process. So now we are switching the heads now from the user's perspective to programmer's perspective, from developer's perspective. Let's assume that we want to implement a tool like this. So yeah, it's Python, so we can write everything in Python, but actually we needed to do it fast because people are using this tool in the way that they create few changes to their slides, then run the script, see what happened, and then modify the code again. So this loop has to be very quick, and pure Python implementation is just not possible. You didn't have enough performance. So one option would be maybe we can use C++. I will now show you how to do it in Rust, and then we can discuss maybe that we can discuss the other solutions. So what we actually want, we have a Python code and some images and some black box that we put all these things together, and we want PDF, mainly PDF as an output, but also some other image format would be nice. So first thing, what we need to do is to have a Python interface. If you have ever used C interface for Python, it's quite, it's lots of boilerplate. It's non-trivial. You have to manually increase and decrease references, and if you forget to decrease the reference, you will have a memory leak, which is quite hard to find, and so on. But actually, the Rust provides you, or there is a module named PyO3, which greatly simplifies all this mess work between connecting your language and Python. And it looks like this. This is a pure pure Rust function that just sums the number for the sake of the simplicity. And now I want to export this function to Python. I want to call this function from the Python code. So how to do it? I will just import the PyO3, and I will annotate this function by this macro py function. Then I have to still create few boilerplate code, but it will just create my module, and I'm putting the function into the module. And it's basically all. Now I will just have to compile it. Normally, normal Rust program would be compiled by cargo, but here the recommended way is to use Maturin, which is, it will call the cargo underneath, but actually it will do also some extra stuff for the Python. So it will just compile the thing, and now from the Python we can just import my module, and I can call my sum and sum the numbers. So there are not many places that I can actually make a mistake. There are not many boilerplate that can go wrong. So yeah, for primitive types it works like a magic, but we can also create more complex structures. So for example, here if I want to export some structure as a Python class, I will again annotate by this macro, and I can also create some methods. So I will basically create the methods in Rust, and one is annotated in new, which means this is a constructor, and other method is just normal method. You can also have a methods that is not exported to the Python, but in this simple case, all methods are exported. And again, small boilerplate, I'm creating a module, and I'm registering this as a class. And now from Python, I can just import the class, instantiate the class, and call the method. So it's quite straightforward. Yeah, another nice thing from the Maturin, that you can automatically generate build or YAML file for continuous integration on GitHub. so your package will be built on different architectures and different operating systems, Linux, macOS, and Windows. For example, there is also this S390, which is some kind of IBM mainframe. I'm not assuming that there will be every person who will build slides on IBM mainframe, but it was for free. Like, I didn't have to do anything to get this configuration, so why not? So Nelsie is distributed even for this quite non-standard architectures. So we have a Python interface. What next? How much time I have? Okay, so yeah. Now there is some pre-processing step. I think that it's not that interesting. Maybe most interesting is the syntax highlighting, because yeah, if you are doing technical stuff, you want to show some source code, so having a nice syntax highlighting is nice. Then there is a layouting that we have to basically compute how sizes of the objects, how big are objects, and layout them. There are also libraries for this. One is, basically the most complex problem is how text is large. What is the width of the text? Because you cannot just take the glyphs from the font and sum the width, because there are different. There is a kerning. The spaces are different, has different sizes, which depends on the different letters and so on. It's a very complex problem. There is a Rusty bus, which is reimplementation of harp bus, which is the state of the art in kerning. And then we have to do the layouting itself. There is a library called Taffy, which is basically Flexbox layouting system as you know it from the browser. So Nelsie basically used almost all features from the Flexbox from the browsers. Then we have to render it. And there are some libraries that can render SVG files and put them into PDF, and there is a PDF writer. Again, this is quite technical and not that interesting. I think that one of the interesting thing is that there is a project called Types. All this PDF stuff is actually done by the people who are working on Types. Types is kind of reinventing LaTeX or tech in the modern way, and it's open source. It's written in Rust, and they created lots of libraries related to PDF. So I'm reusing them. Actually, I'm also thinking about reusing Types as one for rendering mathematics, because this is like the biggest missing feature in my approach. And so far, it looks that it could be possible, but it would be some work to integrate it, because Types is a relatively big package, and all these previous PDF things was already shipped with the small packages, but the mathematics itself is in core of the Types, so it cannot be easily extracted. But I think it could be possible. So we have all these things, and as I said, we want to speed. So we want to make it even faster, and we want to make it parallel. So how we can do it? Yeah, there is a really nice library called Ryan in Rust. So let's assume that we have this simple code. Like I have some computation, I have some data, and I want to apply the function on the data and then collect the results. So this is super standard Rust code, and now I want to make it parallel. So everything, what I have to do is just import the Ryan, and then instead of iter, I'm just calling method par iter. And it will spawn some thread pool and things like this. It has some very nice features because it implements work stealing scheduler, which is quite sophisticated. So you can also have some kind of fork of the tasks, and you can combine it together. So in this compute, you can fork if you need, and then again recursively parallel do some par iter over some different collections and so on, and it will be efficiently distributed across the threads. So I really like the library, but I think that it's not that big deal because thread pools are basically implemented in lots of other languages, basically in every language. But I think that the selling point here is the combination with the Rust, because the most tedious work is not to use the thread pool, but I'm using like 10, 14 dependencies, and if I would do it in C++, I would have to carefully check all the libraries and read their documentation about thread safety. And not all libraries are actually documenting it. And this process would have to be done not only once, but every time they release a version. Because having something about the threads, it's quite complex contract. Can I use this in different threads? Do I have to log something, some specific mutex or not, or is it atomic, and so on? But in other languages, it's written in natural language. And it's my responsibility to read all these libraries, or this documentation of these libraries, and be sure that I'm matching the contract. But in Rust, it's different. So this contract is written in the type system itself. So using Orion is much more easier because you don't have, of course, it's still a good idea to read the documentation of the library you are using, but if you are misusing it from the thread perspective or multi-processing perspective, multi-threading perspective, then the compiler will tell you that you are doing something wrong because the contract is in the type system, not only natural language. So let's just summarize it. Of course, this is some kind of hobby project for me, so I can implement it in whatever language I want. But I think that even from pragmatic perspective, using Rust is pragmatic choice because all the libraries are there. It has super nice Python interface, and it can be parallelized fearlessly, let's say. And it has nice tooling. Like if I had to use like 14 dependencies in C++, it would be quite pain. So thanks for listening. This is end of my talk. I think that it will be not that difficult. I'm actually thinking to create like own renderer, and in this step definition, I can, for example, allow something like I can see them as a key scenes, or how it's called in keyframes. So, thanks, keyframes, and then I can just make some smooth animation. But after I think that it has quite low priority for me. Like there are still lots of things that can be improved. And it's much more useful for the presenting because in some sense I'm creating animations, but it's like animations that I can control the speed. If there will be some predefined, some smooth movement, then I somehow feel that I'm losing the control, and so it has no priority for me. But it's definitely possible to extend the tool in this way. Your own binary.
Your own binary that renders in 60 FPS. It might look cool, but yeah, there are some reasons why we prefer PDFs.
Definitely, yeah, I totally acknowledge that. Yeah. But my point was, if you already have this sort of declarative, I know it's imperative, but sort of declarative input, you could render both. You could have both the PDF and the smooth animation. That was my idea.
I hope like in 14 days I have some preliminary version, because this is something that I don't understand. There are lots of people that asking me to implement hyperlinks, and I will do it, but I somehow internally disagree with it, because then for me the slides is part of the talk. Like having slides as a document is, I feel that it's something wrong. So, and so I don't like, yeah, I will do it, I will implement the links. With the new, I have to recreate, like 14 days ago, I created a new PDF renderer, and now it can, the links can be done. The previous one didn't support it when I reused some existing packages, but now the links can be done. But yeah, for me personally, it's a controversial topic, but I will do it.
First of all, just to follow up on that, you don't have to generate just one PDF. You could also wait to do the one for actually presenting and another one for distributing later, and only the latter can have the links. You know? So you could have present without the links and have one for people to send out that does contain them. So
Yeah, okay. If the link will not be, it's mostly like some command to PDF that it should, if user click on something, then it opens some URL. So it's, yeah, the underline is visible, but all these effects.
I don't know, just like you said that there are philosophical differences with like, if you don't like having links on the slides themselves, then there are ways to go about that without actually.
Yeah, okay.
But I have a question. Have you considered, or perhaps you even exist already, having a Rust API so that you could control multiple libraries from Rust and not from Python?
Yeah, it was actually the original comment from Jakub that originally it should be two crates, like the core and Rust and Python API. The current version is just one crate, but it's designed in a way that it can be separated in the case of need. But I'm not sure actually how it would be useful in practice, because the compilation time is not that great if in this iterative process. But yeah, it can be done. It would be not that much work actually.
Just to give you an example of like a real presentation implemented in this. So this is my previous talk that I would like to zoom in.
But it's a previous version, so it has some caveats that it's fixed.
I will make this zoom once more. So as you said, this idea with the two versions of the slides, I already did that a few times. So for example, the QR codes that you saw in the presentation, they're actually generated dynamically by Python. So I have like a library for QR codes. I give it a link and it generates the QR code. So I could have like an if condition. If this is the version for presentation, generate QR code. If this is the version for distribution, generate the actual link. Because when you're on a PC, it's quite annoying to go through a QR code. So yeah, and that's why I wrote the hyperlinks. So yeah, so just this was like 300 lines of Python. It could be much shorter, but I didn't bother. And it was, I don't know, maybe how many slides? Where does it show the number of slides? 45, yeah, so that's, I mean, it kind of depends, but it is not a lot of code, and I can do this nice thing that I have the little ferries peeking out in the top right corner, so that's like a watermark of all my presentations created in this. So it's a really great tool, and I'm really thankful as I created it, because it's really nice. I need to switch to 5th generation.
Any other question?
I have one more question. What's the second closest tool to Nelsie? And you said previously there are other tools that are not satisfied with some features. And when I would want to use Nelsie, perhaps in a team or something, and I would be like, oh, this tool is in Rust, or I don't like the syntax or whatever. Is there another tool which is close to Nelsie, or it's one of a kind? There's nothing like.
Yeah, to be honest, my idea was not I want to create a tool about slides. I wanted to create slides, and I was super unsatisfied with any existing one. So if there is no, so I'm not aware. I think that yeah, the Beamer provides some features like this revealing, but okay, now I'm super biased. I really don't like the Beamer because I think that it's completely, probably it's a better topic for the pub, but the tech is built for the documents and for writing lots of plain text, not for the, like, but in slides you need lots of layouting, lots of changing things, and you are writing actually relatively few text. And I think it's much more important that you can easily do the cycles and conditions, but I don't know how many of you actually do the cycles and conditions in tech, like, and the error messages of the Beamer is like several pages of nonsense. So I would just say that the Beamer is like the closest competitor, but it's like heavily handicapped on every possible thing. I think that there are some, yeah, what is the?
We actually have a state-of-the-art comparison section in our documentation. So
Of the previous generation.
So we also written some blog posts about this, like we really care about this stuff. So yeah, PowerPoint, no. LaTeX, it's kind of programmable, but you need to program in LaTeX, which sucks. Then there is Reveal.js, which is actually quite nice, but it's declarative. And like creating this Aristotle
C of Aristotines.
Blah, 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 in declarative HTML or in pure JavaScript, yeah, no, it's kind of annoying. And then we know Prezi, which is kind of like a flying 3D presentation in 3D space, okay? And there are actually some Python packages that implement slides. There is Python PPTX, which allows you to create PowerPoint presentations with Python, but it's still a PowerPoint presentation, so it doesn't have the API that we want, I think.
It's quite very primitive. You can just put the text and images on the fixed positions. I think, at least when I looked last time, there was no layout engine. You have to compute manually. If you want to center something, like you have to compute manually. So
there are some markdown-based tools that, I mean, all these tools are pretty nice, and the slides are either simple or they suck. Most people just, agree that their slides will suck or they don't care. But if you want to do these kind of presentations that we are doing with Elsie, yeah, I don't know how to do it without Python or without actual programming, because like my slides, my presentations usually have like 300 slides.
Physical pages in PDF, let's say.
Yeah, physical pages, like, yeah, I go through them very quickly, just animations, but it's 300. Like, I don't know how to do that without coding in Python. So if anyone has a better tool we would like to do, we just, yeah.
If I may just interject, I think the tool somehow shapes, how you present. I mean, if you are using your tool, you probably do precisely what you need. You
Exactly.
do a lot of programming, showing like algorithms or whatever, something that needs some kind of programmatic progress. If you are, if you are an artistic person, you might use Prezi and do a lot of this zooming in, zooming out. But that's not for everybody. If you are using PowerPoint and you are just using set of images, many people just have this style of presentation, and PowerPoint is perfectly fine for that. If you need a lot of bullet points and some math, especially nicely rendered, I would still use Beamer for that. If bullet points and formulas are my bread and butter, then probably trying to stick this into your tool would be too complex.
Yeah, the math is still.
Whatever you need, you choose the right tool for that, but it also works in reverse. Whatever tool you stick with, it shapes your presentation. I mean, I have tried several times to use a video editor, like something like Adobe Premiere to generate slides, and it looks completely different than anything else, but it's also a way. So maybe just to add to the point, you
display all at once, and they just, I think that's just a terrible way of presenting.
Yeah, and that,
in general.
but it's not necessarily the fault of the tool, it's the fault of the speaker or the presenter to
Yeah.
decide to
But
change
again,
it.
I understand it because doing it like bullet point by bullet point or like redoing stuff, it's just too much work in PowerPoint. So that's kind of like if you have the tool that makes it easier, you will do the slides in a different way. If you have PowerPoint, I'm pretty sure I know already how the slides will look like. So that's kind of, I mean, you can do nice slides in PowerPoint, but it takes a lot of work.
Yeah, actually, no one person that can in Google presentation tool, this in the Google Docs, also the objects can appear, disappear, moved as she wants, but she is just the single person in the company, and nobody of her colleagues is able to edit the slides, like literally. So